and the Power Cube was designed to be worked with this home cube system. First of all, I want to reiterate that innovation, true innovation, results in 10 times order of magnitude improvements, and that's the real strength of the home cube system, because it achieves this in 3 different ways: the cost per square meter, the speed of construction, and the amount of greenhouse gas that is emitted during construction. But I want to talk about the housing crisis that we're facing, and the team before did a great job doing that. It's a real global problem that that's getting worse. Like the team before said, it's predicted to be 1.6 billion people by the year 2020. That's 400 million more people living in slums, living homeless, living in unaffordable housing, and that's unacceptable. But also, it's a $1 trillion industry. That's meant to say 16, and I think even a small innovation in this area that targets particularly the lower end of these communities has an enormous potential for change. So I want to focus on the 3 main aspects that the home cube differentiates itself from anything else on the market. So the home cube can be built 9 times faster. So imagine one person with a spanner and a shovel, and they're working on constructing houses of 9 lots, and they don't have any special expertise and no heavy equipment, and yet they managed to build 9 houses in the same time that it takes for a conventional house to be built by a team of engineers, teams of tradesmen, and much larger investment. The second thing is the home cube actually absorbs a net amount of CO2 emissions. So a home cube that's the same size as an average Australian house will absorb 30 tons of CO2 emissions. Now this is in comparison to 40 tons for the average 40 tons emitted by the average Australian house. So this is huge because the home cube will particularly benefit developing countries. And developing countries are the ones that it's the hardest for them to meet the climate change objectives. And this will be a powerful weapon for them to meet those climate change objectives while housing the population in a cost-effective and fast manner. So I want to talk about the competition, and this really boils out from it's 11 times cheaper to build a home cube per cubic meter. So cubic meter is on the left-hand side, and you can see that the home cube is here at $30 per cubic meter. And that's with 100% contingency added in from the basic structure. This is similar to slum tents, which, as I described earlier, I've surveyed and I've gotten accurate measurements from in Hyderabad, India. The slum tents have a disadvantage that they have a very high maintenance cost. It's 100% of the initial cost every year. The standard housing is over here. This is the average for Australia. It's about $1,000 per square meter. Then the IKEA Refuge Shelter is the best permanent structure I've seen out there. But if you compare the functionality and the cost between the home cube and the IKEA shelter doesn't have a floor, it's difficult to construct, and it doesn't have any plumbing involved with it. So given all that, we've determined this price corridor, and we want to target the lower end of the price corridor so that we include everybody and tap into that enormous latent potential that's out there. So before I go any further, I want to introduce the home cube team. So I'm David. I graduated in physics and chemical engineering from the University of Queensland just a couple of months ago, and Since then, I've started a 3D printing company, a profitable one that has really taught me a lot about starting businesses. And Natasha?
Hi, I'm Natasha. I'm studying civil engineering at UQ. I was in charge of the marketing and the structural side of HomeCube. So I tried to come up with a strategy to try and improve audiences for our Facebook site and also improve our content so it could target the wide demographic. I also helped set up our new website using the Squarespace platform. With the structural side, I conducted structural load analysis using computational software like SISCA to ensure that HomeCube met the regulatory requirements.
Alright, hi, my name is Andrew. I'm a third year civil engineering commerce student. So for the HomeCube, I was more involved with the finances because ultimately money is always involved in a project. So we had a $2,500 budget and I had to allocate who gets what in the most efficient way possible while minimizing waste.
Hi, I'm Gabby. I'm a third year civil and IT student. I was involved with the calculations for different locations that would be on the HomeCube, also in the design of foundations for those varying loads.
Hi, I'm Will. I'm a fifth year electrical engineering and computer science student. So my task was to investigate embedding RFID chips into the actual panels itself, and also developing mobile applications to find out more information about the panels, as well as using the Internet of Things technology to potentially embed more smarts into the panel and, like was mentioned before, the power cube system. So using the Internet of Things, we can monitor the health of the structure itself if there's any potential issues, to quickly resolve them, come along and resolve them before they go out of line. So, for example, battery management systems. By using the Internet of Things, we can say whether the battery pack is getting near its lifetime use, and potentially warning them saying, do you want to upgrade or replace the battery pack? Yeah.
And we've built the bare bones of that system at the moment. So I want to explain how we've achieved this incredible innovation. The HomeCube's based on simplicity. There are 4 main components. There's the connector, the tube, the panel, which you can see there, and then the concrete foundation block. So the connector is the key, and this is patentable. This it connects to a panel, a tube, as simple as twisting onto the tube. And as you do that, you connect up the structure and the plumbing and the wiring all in one go. Now this is done because, and it's as simple as putting together Lego, this is done because the tube has an aluminium tube pipe that runs through the end. It's threaded on both ends in opposite directions so that you can thread in to 2 connectors at once. And so the water will, this pipe will be a conduit for the water, and there will also be wiring that goes through this tube that connects up to the connector at the end. Now this connector had been 3D printed. That's just for demonstration here. It will be founded out of metal, and I'm talking to foundries in Brisbane at the moment to make that a reality. The other component of the HomeCube is the panel. This is a panel that I got the internal so that you can see. This will be for the floor. It'll have corrugated iron that makes it sturdy enough to stand on. Also, every panel will have this foam or rubber. So when you slot it into the steel frame, it will compress, forming a watertight seal. And finally, the last component is the foundation block. And the HomeCube will be raised above the ground with the floor. And basically, you dig a hole, you place a foundation block in it, and then you place steel tubes, and then you can keep sliding down foundations. The reason why I made the foundations modular is so that no component of the HomeCube weighs more than 15 kilos. means that you can carry it around. And I transported all this from Bundaberg yesterday. And the idea is that you can make it very transportable. Also, the key, another key aspect is that you can take it apart as well as put it together. So this is really crucial for slums who are built on illegal land and could be evicted at any time. They're afraid to invest in structures, even though they often have the money to do so, because they would have to tear down their structures if they did that. So they could just unpack it and move it to their new location. So we won second place in this competition last year. We, like Andrew said, won $2,500. And that was, we've gone so far with that. We've made an active Facebook page and website, had an international conference in Singapore for Science of Future Cities. I went to India for surveying over 50 slum communities. We built, probably most impressive, we built a 3 by 3 by 3 meter prototype to test out the idea, and that's in the middle at the bottom. And we've conducted structural analysis using computer software. So if we win this competition, this is where your money will go. We have a proven track record. We've already used your funds to get to this stage of development. So the equipment cost will be $3,500. We want to build a full-scale prototype using this system by the end of this year, and that will cost approximately $3,000. And we aim to use that to conduct structural testing to see how strong this home cube is, because although it has more structural steel involved, it's segmented, so the dynamics of that are interesting. And testing will cost about $12,000. And that's based in Townsville and here at UQ. And we have already established contacts in both places. And we're ready to go once the prototype has been built. And basically we'll use your funding to get to the next stage. And the next stage is a Kickstarter campaign. So we'd love to tell you about the Kickstarter campaign. So please like our Facebook page or visit our website, and so that we can keep you updated when that Kickstarter campaign happens after the testing, which should be in the first half of next year. So I just wanted to emphasize all the industrial contacts we've made. The reason why we can so accurately predict how much it will cost is because we got real quotes from international companies who will provide the best mass-produced price for the. But we haven't just contacted suppliers of the material. We've also contacted distributors. Pollinate Energy has expressed interest once we've got a functional prototype. Diego has said that he has contacts with the Paraguayan government officials, and so that's maybe another option to pursue. And based here in Australia, I've contacted, Storage Solution product has, storage business has expressed interest in purchasing this product. So in summary, why us? Basically, the need is enormous, but it's not just housing that the home cube addresses. It addresses renewable energy using the power cube. It addresses sanitation because you capture and use rainwater. It addresses health because you're now living in a clean environment. The home cube is as close as it comes to a magic bullet to all the world's problems. But also, the approach, we have already developed industry contacts and made several functioning prototypes. The originality and the value is that it would confer to customers. So we need your help to get this started, whether it be through a Kickstarter campaign or the funds from this competition. And I believe that this has unparalleled potential in the world. So please help us make the HomeCube a reality.